Hello everyone, this is Vardman and welcome to our new course on data structure and algorithm.
This course will be divided into two parts. One will be data structure and other will be algorithm. First we will learn algorithm in our first course, and for data structure there will be a separate course. This course will be on algorithm. Let's talk about the structure of the course. The course will have multiple topics like analysis of algorithm, divide and conquer, greedy algorithm, dynamic programming and many more. So for each and every topic, we will be covering its theory and pseudocode. All the theoretical concept and dry run of the pseudocode for each and every algorithm will be covered. Second will be time and space complexity. So we will be analyzing the time and space complexity of each and every algorithm. So this will help us to choose the best possible algorithm for a given problem. Third will be interview questions. So this will be interview questions, or we can say knowledge check, that we will be doing after every algorithm we will study. So these questions are frequently asked questions which are asked in top product based companies. And the last will be implementation. We will be coding each and every algorithm that we are going to discuss. Generally we will be coding in C++ programming language. Now let's talk about who can follow this course. Student can follow this course if they are preparing for number 1 placement. Top product based companies ask data structure and algorithm in their coding and interview rounds. So this will be very helpful in placement preparation. Number 2 will be semester exam. Usually colleges have data structure and algorithm subject in their second year. If you follow this course, then you can ace in your semester exam. Third is GATE exam. Student preparing for GATE exam can follow this course. If they complete this course and practice enough questions, then they can face the GATE exam head on. Next is prerequisites for the course, or the things you should know. So there will be only one prerequisite, that is a programming language. Any programming language will be fine to learn this course. For theory, we will be writing pseudocode, so language will not be a barrier in it. For implementation, we will be using C or C++ programming language. So in that also basic C or C++ will be enough. You should just know basic conditional statement like if, else, switch, and loop like for, while, do while. There will be no requirement of oops concept, so if you don't know oops, then it will be fine. Now let's move on to the content of our algorithm course. The course is divided into 5 major parts. The first one will be analysis of algorithm. There are multiple algorithms available to solve any particular problem, but to solve the problem efficiently, we need to find a best possible solution. Here we use analysis of algorithm to find the best solution in terms of time and space complexity. Under analysis, first we have types of analysis. There are two types of analysis. First is a posteriori analysis, second is a priori analysis. Under a priori analysis, we have time complexity. We will be learning how to find time complexity of a given algorithm. We will be covering time complexity and space complexity as well in this. The second one is asymptotic notation. This helps us to represent space and time complexity in terms of notations. There are a total of 3 notation available. One is big O, second is omega, and the last is theta. So these 3 notation we will be learning. The third part will be recursion. So this is a very important topic. It is mainly used in divide and conquer and dynamic programming. In recursion, we will be learning how recursion works with the help of multiple examples and how to write recurrence relation for a given recursive function. We will also learn how to solve recursive relation. So there are a total of 3 methods available to solve recursive relation. They are substitution method, recursive tree method, and master theorem. We will be learning all 3 methods, and we will be doing multiple examples on solving recurrence relation to find space and time complexity for a given algorithm. In the second part, we will be learning divide and conquer algorithm. We will be learning basic of divide and conquer algorithm, and we will find time complexity of various divide and conquer algorithm. We will be learning different applications of divide and conquer.
So we will be learning a total of 9 applications, and they are: number 1, finding maximum and minimum element in an array, power of an element, binary search. So in binary search we will also be looking at linear search. Fourth is merge sort, quick sort, selection procedure, stress and matrix multiplication, counting number of inversions, finding max continuous sub-array sum. So these 9 applications we will be learning, and also we will be coding them as well. Third part, we will be learning sorting techniques. We will learn different sorting techniques and we will analyze them. We have already covered quick sort and merge sort in divide and conquer. So rest we will be covering here. So we will be learning first bubble sort, selection sort, insertion sort, heap sort. Here we will learn every concept that is required. So suppose in heap sort you should know binary tree and heap tree. So these all things we will be covering here. Fourth topic will be greedy technique. Greedy technique is an optimization algorithm which make choices at every step. It works on principle of taking the best option at every step, and later these steps are combined to make an optimized solution. Here we are going to learn different application of greedy technique. They are job sequencing with deadline, knapsack problem, Huffman coding, optimum merge pattern, minimum cost spamming tree. In minimum cost spamming tree, we have two methods: Kushkal algorithm and Prim's algorithm. Single source shortest path, and in this we have two algorithm: Dijkstra algorithm and Barbenford. And here also we will learn graph and tree before going for these algorithms. In the last part, we will be covering dynamic programming, or in short DP. In dynamic programming, we solve bigger problem by dividing them into smaller sub-problems, and we store the solution of those sub-problems, and these stored sub-problem solution are fetched later to solve the repeated sub-problem. This removes the redundancy from the solution. There are some applications of dynamic programming that we are going to learn. They are: first, Fibonacci series, 0 1 knapsack. So this is a slightly different knapsack that we have learned in greedy technique. Sum of subset, matrix chain multiplication, all pair shortest path, and longest common subsequence.